Hey guys, so today we're going to be multiplying polynomials, and I'm going to give you multiple ways in which we can do this. But really, you can pick whatever way works for you and then go for it. Okay. Now, there are two examples here with distributing and the box method. I'm going to stick with the box method right now because I think it's a little bit more organized, but you can do what you need to do. Okay. So with example 5 here, this is the binomial times the binomial. Now, some of you might have learned in the past that you could do what we call FOIL, first, outer, inner, last. Again, I'm going to do it by box method because I'm going to organize it just a little bit more. So we make our box. Okay, and it doesn't matter which parentheses, I guess, is on the top or on the side. Either way works because remember, multiplication is commutative. You can switch it back and forth. So this would be 5x minus 7, and this is 2x plus 9. Okay, and then what we're going to do is multiply. One thing you need to remember is your coefficients. You're just going to multiply those numbers. Your exponents, your variables with exponents. Remember, when you multiply, you add those exponents together. So 2x times 5x is 10x squared, right? Because 1 plus 1 is 2. 2x times negative 7 is negative 14x. 5x times 9 is 45x. And negative 7 times 9 is negative 63. Now with your boxes, what you're going to do is combine like terms, okay? So I can see that I'm going to add the x's together. That doesn't change the exponent because we're adding green apples and green apples, right? So we're putting them together and saying how many. So our answer becomes 10x squared plus 31x minus 63, and we're done. Okay. Very logical process. Now in example 6, you need to watch out because the common mistake is saying, oh, we're squaring it. So why can't we just make both of these two terms squared? Why can't we just make this 9x squared and then negative 4 times negative 4 is a positive 16? Well, we can't because the thing is you're not distributing that squared. What this actually is saying is 3x minus 4 times 3x minus 4. So sometimes rewriting that out allows us to see that multiplication a little bit better, okay? What I'm going to do right now is just show you the example because I would do this the same way that I did example 5 after I expanded it. So again, what I'm doing is I create my box. I have 3x minus 4 times 3x minus 4. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. Negative 4 times negative 4 is positive 16. Okay, and I combine like terms, right? Those x's right there. And I end up with 9x squared minus 24x plus 16. So if we go back to that common mistake I was talking about, and if you distribute the square out, you'd be missing this middle term. Okay, you'd be missing that, and you don't want to. Otherwise you'd be incorrect, right? Okay, so those were binomials times binomials, right? And this is why I love the box method so much, because it allows me to organize my work. And right here we have a trinomial, a binomial times a trinomial. What I'm going to do, because of the little space that I gave myself and you, I'm going to put the trinomial on top. So I'm going to put the 6x squared minus 7x minus 5. Okay. And then I'm going to put the 2x plus 3 on the right side. Okay. So again, I'm gonna multiply each box here. So 2x times 6x squared is 12x cubed. 2x times negative 7x is negative 14x squared. 2x times negative 5 is negative 10x. Now, watch your negatives because sometimes we forget our negatives. And if you forget to change the exponent by adding the exponents, right, you see that in my row here, there's none of the same exponents. That's how you know you did it correct, or at least you're on the right path. 3 times 6x squared is 18x squared. 3 times negative 7 is negative 21x. And 3 times negative 5 is negative 15. Okay, again, all the exponents are different in this row. Now we're going to combine like terms. The great thing about combining like terms is that they are usually diagonal. See the different patterns that would help us go through the process. Okay, so we have 12x cubed. Now be careful, this is 18 minus 14, which is 4x squared. We have a negative 21 and a negative 10, so that's a negative 31x, and then minus 15. Awesome. Okay, what I want you to do is pause the video and see if you can do this trinomial by trinomial. I do this because instead of me spending time writing all that stuff out, I'm going to show you the answers. So like I said, pause the video, try to do the trinomial times the trinomial. Okay, hopefully you tried that by yourself. So as you can see, I had to write a little bit smaller just because of the space given. If you don't have enough space, go get another piece of paper, do it on the back side of your packet, whatever you need. So I have this 2x squared plus 4x minus 3. I have this 6x squared minus 3x minus 8. Okay, so let's make sure, double check that I did this. 6x squared times 2x squared is 12x to the 4th. 6x squared times 4x is 24x cubed. 6x squared times negative 3 is negative 8x squared. Okay, next row. Negative 3 times 2x squared is negative 6x cubed. Negative 3x times 4x is negative 12x squared. Negative 3x times negative 3 is positive 9x. And then we have this last row. So we'll end up getting negative 16x squared, negative 32x, and positive 24. Again, when we combine like terms, right, we end up with them. So we add them together. I get 12x to the 4th plus 18x cubed minus 46x squared minus 23x plus 24. All right. Next, just like we did, actually we haven't done it yet. This is me. In multiplication, sometimes there are some shortcuts. But the shortcuts are only with certain types of problems, okay? So what they're called is polynomial, because that's our polynomials, multiplication, but they're identities. So if you have the same setup, like the difference of squares or squaring, just like we had that, what was it, 3x minus 4 squared, right? Those are certain patterns that always happen. And polynomials identities will allow us to go through that maybe a little bit faster. Now, do you have to use the identities? No, but I do want you to practice a little bit in case you like it. So one of the things with the identities that we need to go over first is our perfect squares and sometimes our perfect cubes, okay? Remember, squaring, you're multiplying something by itself. Cubing, you're multiplying something by itself 3 times, okay? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Now, some of you might not know these by heart. You can always use your calculator. 11 squared is 121. 12 squared is 144. 13 squared is 169. And then we stop right there because we're not going to try to go crazy and do bigger numbers, but you can. 1 cubed is 1, 2 cubed is 8, so 2 times 2 times 2. 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 6 cubed is 216. 7 cubed is 343. And no, guys, I do not know all these by heart. I have a cheat sheet right next to me. So now, one more thing. I hope that this sounds familiar. If it doesn't, we might have to talk about complex numbers. But so where does an imaginary number come from? Well, when we did radicals in years past, you find that, wait, we can't have a negative number under a square root or an even root. So we had to play with that a little bit, right? Well, if you remember, an imaginary number is actually the square root of -1. Okay, so that's something good to remember. Now, I squared. Well, let's break it down. I squared would be the square root of -1 squared, correct? So that indicates that I squared is the value of -1. Awesome. Okay, these are the identities. Now we're going to stick with multiplication right now. Okay, so with multiplication, what we're going to do is we're going to look at the left side and actually calculate it to make it the right side. So left side, calculate it to be the right. So these are the different type of polynomial identities that we are looking at. We have a perfect squared. Okay, that means we have a plus a b in all of that squared. We also have it where it's subtraction. And every time it will always come out to be in this format. It would be a squared plus 2 times whatever a and b is plus b squared. That's it. That's the identity. You could memorize that if you want. Then we have our cubic, where we're cubing. We have our difference of squares. We see that it's a difference of squares because we have one adding and one subtracting. But as you can see, the term A is still the same in both, and the term B is still in both, okay? Now, the sum of squares, this is where an imaginary might come out, okay? And it actually ends up coming out to a squared plus b squared, okay? And that's where we have to square that I, right? Okay, and then we have a sum of cubes. So we have this binomial of a plus b times a trinomial. And the trinomial specifically is a squared minus a times b plus b squared. These two here, the sum of cubes and the difference of cubes, are probably harder to recognize because really this has to be this trinomial. It can't be any trinomial, okay? So here are the steps in using the identities. First, you want to identify what identity you're using. You want to identify what the A term is, what the B term is, and then you substitute. Okay, again, this is more of a memorization thing, but I want you to try it out. Okay, so we have some examples here. Okay, now 4x plus 3y squared. Remember, this is the perfect square. So the perfect square, I'm going to write that out, okay, means that this is my a term, this is my b term, and it's supposed to equal a squared plus 2ab plus b squared. And again, I got that from the other page. This also tells me that a is 4x and b is 3y. Okay. So now all I have to do is substitute that in. So 4x for the a, and then 3y for the b. Plus I gotta take that b again and square it. So see, all I did was I identified what polynomial I'm using, what identity I'm using. I identify what's my a and b, and then I substitute in. Now I'm actually going to calculate. What is 4x squared? Well, that becomes 16x squared. Okay. 2 times 4 times 3 is 24. And x times y is just xy. And then 3y squared is 9y squared. And we're done. This is our answer. Okay. All right, and B, this is the difference of squares. I know this because A and B are the same and the signs are different, right? So if you look at the other page, the difference of squares tells you that the outcome is going to be A squared minus B squared. Okay. A in this case is 2x. B in this case is 5y. Okay. So now I substitute in, so I have 2x for my a and 5y for my b. Then I'm going to evaluate that, right? So 2x squared is 4x squared. I know that sounds weird, right? Minus, and then 5y squared is 25y squared, and we're done. Nice little trick. Now, tricks. Anytime I have cubics, I like tricks for the fact that if I did the multiplication by box method, I would actually have to do it twice. I would have to go 4x minus 5 times 4x minus 5, and I get a result. And then that result, I would then have to multiply by another 4x minus 5. So sometimes I like tricks. So if we look at the other page, the difference of cubes, no, it's not. Yes, it is. Did I say it correctly? Cubic, it's just cubic. Difference is down here. You just named it differently. Okay, so our cubic polynomials, right? It comes out to, don't forget, this is subtraction, so make sure you get the right one. Okay, so this ends up coming out to be a cubed minus 3a squared b plus 3a b squared minus b cubed. Okay. So in the addition, it would all be addition, but since it's subtraction, it's every other one. Okay, our a in this case is 4x, and our b is 5. It is not negative 5 because I've already put the subtraction in this idea. Okay, so a is 4x and b is 5. You see that? Okay, so let me write that in. So 4x cubed, like that. There we go. Minus 3 times our a squared times b times a times b squared minus, yeah, like writing everything out nicely, 5 cubed. All right, so this is where we go back to like all the problems I said at the beginning with the perfect cubes and perfect squares. So this ends up being 64x cubed minus 240x squared plus 300x minus 125. A little bit faster than trying to do the box. Now, that means they're both, you come up with the same answer, except one's probably quicker than the other. All right, and here, now we have the difference of cubes. So again, a squared right here, so that's 9x squared. This is a times b, and that's b squared. So that's how I know the trinomial works for the difference of squares. And I know this answer is coming out to a cubed minus b cubed. So a in this case is 3x. B is 2. So I have 3x cubed here minus 2 cubed. So our final answer is 27x cubed minus 8. All right, so just going back, what if it doesn't fit a pattern? Okay, remember, this is binomial times a binomial. With our identities, we had A and B and stuff like that, right? Well, if this were A minus a B, right? This would be an A plus a C value. And we don't have an identity for that. So we can't use identities, and that we'll just have to go back to our box method or FOIL, depending on what you like better. Sometimes the more you multiply polynomials, the faster it comes to you. So this is x squared minus 2x, 5x, and negative 10. So our final answer is x squared plus 3x minus 10. Awesome. In our next video, I'll give you another way to multiply. Again, just an option that you can use if you want to.